Okay. Now, the very, very first thing that we have to talk about when we're talking about physics, and I know I have some people who are coming in here with out a previous physics class, and that's perfectly fine. You don't have to have regular physics before AP Physics. So I guess we just need to talk about in general at the very beginning, like what is physics in general? So like whenever you talk about physics, what are we talking about? I'm looking at anybody. No? Okay, well let's go into a little bit. Let's try to like focus this down at least a little bit then. Physics is a what? It is a science, okay? So it is part of a science regiment. So there are three main branches of science. Does anybody know the three main branches? We've got physics, we've got biology, and we've got chemistry. These are the three basic parts of science. Now, does that mean that there aren't other sciences? No, there's all sorts of stuff. If biology and chemistry get together and have a baby, you get biochemistry. If physics and biology start to intertwine between each other, you get biophysics, which is its whole different kind of thing. Physics and chemistry, there is a physical chemistry. It is like the physics of chemistry, and it's extremely frightening. If you take a physical chemistry class because you have to in chemistry in college, be prepared. That stuff is not for the faint of heart. Um, that stuff's crazy. That stuff will make Mr. Broadway crazy. But it's also can be highly rewarding at the same time because those careers are usually very, very lucrative. You just have to survive physical chemistry to be able to do it. It's a thing. Okay. Engineering is more like an applied physics. Engineering is how to take the stuff that we learn from physics and how to make useful things out of them. Physics itself is a specific study. So we study and we gather information. That's what science is in general. If you're talking about a science, you're talking about gathering knowledge and using that knowledge to either answer questions or to just gather the information, because sometimes you're just gathering data. In our case, we're going to use it to answer questions. I don't really think gathering data for the sake of gathering data is very fun. So I think we'll use it to answer questions. What does biology study? Yes, biology studies life. What does chemistry study? Kind of. It studies matter, which is chemicals. Chemicals count as matter, right? Like if you've got hydrogen peroxide, that's a chemical, but that's also made of matter, right? Physics studies what? Physics studies energy. Okay, so whenever we talk about physics, really what we're talking about is we're talking about the using of energy. Okay, so physics is the study of energy. If you wanted to break that down into just one big thing, this is what we're going to be using. We're going to be talking about the study of energy. Okay, now to go into a little bit more depth, because what is energy? If I say energy, what does that actually mean? Take a chance. Go on a limb. When I say energy, motion, heat, yeah, those are definitely types. Like if something's moving, it has energy, right? If something's hot, it has energy. So the ability to do work is the actual, like that's the textbook definition. So energy is the ability to do work, and all of those things that we mentioned are manifestations of that ability to do work. So, all right, ability to do work, because now we have to answer a whole nother question. What is work? Okay, because like these fancy broad textbook concepts, they sound good, but they don't make a whole lot of sense whenever you just look at it. Be like, oh yeah, energy is the ability to do work. Be like, all right, hot shot, what's work? And be like, I don't know. So like things that are moving things definitely have energy. Okay. Things that have heat definitely have energy. And there's other examples that you guys can think of energy. Electricity. Okay. So electrical energy is also a thing. and we'll study a little bit of electricity in this course. Uh, Hydroelectric energy, right? So like we're thinking power plants now, right? So like there is a hydropower, right? Hydroelectric. Okay. What other kinds of energy? I mean, we're there. Wind, it's a thing. Can literally being alive work? How are you alive? Well, that's a that's not a scientific question because if I say how are you alive, um, how do you keep moving? Yeah, you do have energy. Where do you get your energy from? Okay, so like, and this one's kind of an interesting one because this gets into the chemistry. You eat the food, but the food is a chemical reaction. So like, whenever you eat it in your stomach, the stomach digests it and it goes through a chemical reaction. So there is a kind of chemical energy, and that one's a little bit tough to remember because we had to get to it from a roundabout way because you're like, well, we're alive, we're doing something, right? We're moving, but we're moving because we use that chemical energy and we turned it into movie energy, which would be kinetic energy. From physical science, they call it kinetic energy, and we're going to call it that too. What other kinds of what other kind of energy is there? I think y'all have pretty much nailed most of them. There is a potential energy, yeah. Some of these are some of these are already potential energies, but we'll go ahead and we'll just go ahead and put that in there. Potential energy. Okay. Any others? Are y'all good? Okay. So I'm gonna count moving things. I'm gonna go ahead and put kinetic up here because moving things is kinetic energy, and that would count. So kinetic energy is up there. We've already got it as moving things. I'm totally fine with that. Going once. Going twice. Sold. You left out nuclear, but that's okay. I'll forgive y'all. Um, it's not that we're not going to really talk about nuclear and AP physics, so I'm not even worried about it. But that is also a type of energy. Now, what if I told you, and this is going to get a little deep, what if I told you that all of these things deal with motion? So, all of these things, whenever you think about it, it deals with kinetic energy and the ability of things to actually move around. Okay, so you've got to have motion in order to have energy. Because whenever you talk about heat, if y'all remember from physical science, heat is actually just little molecules that are wiggling around in place. So the hotter something is, the faster those molecules are moving. The colder something is, the slower those molecules are moving. So electricity is the same way. If you have an electric current, that means that there are literally electrons that are moving through a circuit. Okay, if you have hydroelectric, that's water that has to go from a high place and it moves down to a low place, and you release that energy in the process, or you change that energy over. Okay, but it has to move. It has to move from one spot to the other. It involves that motion. Wind is the same way. The wind actually has to cross through the turbine in order to be able to do that. Chemical potential energy is a little bit harder to explain, but the chemicals, all of the atoms inside, have to move and get rearranged in order for the chemical process to unlock and occur. Okay, your batteries are also an excellent example of chemical energy as well. Okay, potential energy, there's a whole lot of different types of potential energy. In physical science, y'all talked about the potential energy of like taking something and then like lifting it up in the air. So as you gain it higher in altitude, you gain potential energy. Whenever you drop it, you lose that potential energy and it turns into kinetic energy. But that involves motion. It had to actually go from one spot to the other spot. Okay, so every single one of these types of energies involves some type of motion to go along with it. Okay, so let's spend a little bit of time and let's talk about motion, um, and we'll kind of use that information to make our lives a little bit easier, I hope. I'm going to move this down. Does everybody have that wants it? I can print this off as a PDF and put it in Canvas too, so you'll have that available to you. Okay, let's motion. How do you measure, or like what is motion, or how do you measure motion? And we said moving things, but with measurement tools? Okay. So like okay, that's a good one. Yeah. So like we're doing motion. How do we measure motion? We measure it with measuring tools. Like what? Okay. So there are speedometers in a car. That works. Okay. There's a what else was there? The meter stick, or you could just say meters, right? Because what's a meter stick measure? It measures meters. Okay. What else would we use? What measuring tools would we use for measuring motion? The car is nice because the car just gives you a speed that goes along with it. A speedometer measures speed. Compass. Yeah, that's totally true. We could use a compass in order to find our direction, and we'll need that. Okay. What else? How do I know how fast I'm going if I don't have a car? If I don't have a car to give me a speedometer, how do I know how fast I'm going? Okay, so we could do it by measuring, we could do a formula, right? Speed equals distance over time. We've got the distance, but we would need something else for the time. A timer. Yeah. So fortunately for us, that's like the easiest one to have because we don't normally have a speedometer in our car or on our person or a meter stick. Sometimes we have a compass, but y'all usually always have timers. Cell phones count as timers. So we can use a timer or a stopwatch in order to measure time. And a timer measures time. Okay. And we did already mention the speed equals distance over time. So I'll go ahead and write that one up there. So if we take our distance that we travel and we divide it by the amount of time that it takes, that speed equals distance over time is going to give us the formula that we need in order to solve for the speed of an object, how fast something is actually going. And an object could be anything. An object could be like a fluffy bunny. An object could be like a giant meteor out in space. It can be as small or as large as we need it to be. So whenever I say like an object, it literally could be anything, or it could be a series of a bunch of things together. We have the ability in physics to completely and totally oversimplify things if you want to. In fact, we do that quite often. If you take a car, which my cars normally look like sombreros, there you go. Okay, so if we have a car, I would consider that car one object, right? But what if there's somebody inside the car? I would still consider that one object. You know what I mean? Yeah, like exactly. So they have the same motion, right? So if they have the same motion, I would probably say that anything inside the car would just be an object. Okay? Yeah, so like if it stops, then yeah, we form the assumption that the object acts uniformly. So we're going to assume, which is sometimes a bad assumption, we're going to assume that if the car stops, then everything else inside the car is going to stop along with it. Okay? In reality, that's not normally what happens, but this is rainbows and butterflies physics world. So everything that is inside it is just going to act uniformly along with it. Okay? Unless they specifically mention otherwise. So you can oversimplify things. And in fact, a lot of times on the AP Physics test, people don't make those simplifications, and it normally hurts them in the long run. They tend to overthink things because they think, oh my gosh, this is AP Physics, this is going to be difficult. And the difficulty they just added to themselves because they made it too hard, they made it too difficult. Okay. So we're going to try to make sure, and that's why I'm talking about like what an object is right now, because if I talk about an object, that really can be just like a whole lot of different things put together. Okay. So a speedometer measures speed, and it has some units that goes along with it too. Okay. So we could measure speed in miles per hour. Or meters per second. Yeah, absolutely. Okay, meters per second is another one. Notice how both of those are distances over times. Okay, so anytime we talk about speed, it's always going to have a unit of distance over time. Okay, it's probably important to talk about right here in physics class. We use the KMS system. So I'm just going to write KMS up here really big. Okay, now KMS stands for kilograms meter. I know a lot of people want to say kilometers. Yeah, it's kilograms, meters, and seconds. Okay. Everything in AP Physics, we're going to try to measure in kilograms, meters, and seconds. And that's just going to make our life a whole lot easier. Freedom units makes things difficult in terms of this because acceleration due to gravity is a nice even number. And if you use freedom units, it is not a nice even number. It makes the math a little bit more complicated. So we use the KMS system, kilograms, meters, seconds. Y'all's lingo makes that a lot easier to remember because KMS means something else to Zoomers, and that's okay. All right, I'm gonna get like stuff like people sending me things in Canvas. What does it stand for, Mr. Broderick? And I'm like, uh-oh. Well, whatever. Yeah, you're like, look it up. Uh, Google is totally a thing. All right, so all of these, the kilograms, the meters, and the seconds, all of these are considered units. Okay. Um, Now, sometimes you can call these the same thing and they're kind of interchangeable. But we're going to spend a little bit of time talking about dimensions. Okay. And I'm going to try to scroll this up so that we can actually see a little bit of it. Dimensions. This one has a lot of misconceptions to it because of the way that people use the word dimensions. Um, Most of the time, as a rational human being, when you talk about dimensions, what would you say? Can you give me the word dimension in a sentence? Yeah, so like if you say like what are the dimensions of the fish tank? You would say like 20 inches by 15 inches and you would give a length and you would give a width and you would give a height. Okay? So that works. Those would be three dimensions. So the fish tank is a three-dimensional object. But then you get those crazy people who start talking about I have done six-dimensional calculations and are they insane? Do you like you don't really know if they're insane or not, or if they're just really big brain, right? But I'm here to tell you that if somebody does a six-dimensional calculation, that they're not actually as big brained as you might think that they are, because a dimension loses physical comprehension for distances past three dimensions. Okay, because if you talk about one dimension, you're talking about just like an individual point. If you're talking about two dimensions, I'm sorry, one dimension would be like a line, not a point. So you can talk about anything along a line, and that would be one dimensional. Okay, two dimensional would be like this. Here, I'm going to do this. So whenever we talk about like a 1D, it's like a straight line across, or at least as straight as I can get it. 2D is anything that you can talk about on a grid. So in algebra, y'all basically do everything two-dimensional. You don't really do anything 3D. Okay, and for a third dimension, okay, so for 3D, you can add depth to it as well, and you can talk about a 3D object. What is that? That is a cube, right? The cube is basically a three-dimensional object because we know that it has three dimensions associated to it. It has a length, it has a width, it has a height. Okay? I will show you a four-dimensional object. Okay? So here, no. See, here's where we've got to distinguish between the like whole like big brain and it that's not true. Like if you talk about a like anything that is further than three dimensions, a dimension is, by definition, anything that is measured. There's not one. There's not one. So a fourth dimension to this object, like for example, if I said that this brick or this cube has a mass of 3 kilograms, this is now a four-dimensional object, okay? Because this object has length, this object has width, this object has height, and this object has mass. So if I include all four of those in there, that makes this four-dimensional, okay? That means that whenever you're talking about density, whenever y'all did densities back in the day, densities are actually a four-dimensional calculation because you do mass divided by volume. Volume is 3D. The mass is also a dimension. So y'all did four-dimensional calculations and you didn't even know that you were doing it. You're just like, I'm just calculating density. Here we go. Okay. So whenever people try to get like super big brain on you and they're like, I've done six-dimensional calculations, be like, big deal. I do four all the time, because whenever we talk about it, a dimension is really just anything that is measured out. So we can add lots of different characteristics to this cube, and those can actually be dimensions as long as we can put a number to it, okay? So like I cannot use color as a dimension because color doesn't have a number associated to it. I can't be like, hey, what color is that? 57. That doesn't make any sense, right? You can't be like, that's color number 57. Be like, no, it doesn't work. Okay, so as long as you can put a number to it, you can actually talk about more dimensions of this box in and of itself. So when we talk about kilograms, meters, and seconds, it's very possible to get lots of dimensions going here. Okay, does that make sense? Okay, that's why I wanted to kind of go over like what a dimension is, because a lot of times we think that a dimension can only be a length, and that's not true. A dimension can also be a mass, and a dimension can be anything that is actually measured out. Okay? Questions? Comments? Concerns? Yeah, you can also yes, that's you're onto something here because it like for example, we talked about speed with the speedometer, right? You can consider speed by itself a dimension because you can measure that speed. So you can talk about speed as a dimension. You can talk about um, the three-dimensional displacement. You can talk about its rotation. You can talk about if it's spinning or not because you talked about an object as it's going here, but you didn't necessarily talk about whether the object was spinning. So that can add three other dimensions to it: spinny, spinny this way, spinny, spinny this way, and spinny, spinny this way. Yeah, the poor digital people are like, "What's he doing?" Like I'm moving my hands in circles on like how they're spinning around. Okay, so yeah, you can have lots of dimensions that can talk about not only the linear motion but also the rotational motion. You could also include compound units like speed, and those can count as dimensions themselves. Whenever I was in college, they used because I used to study in nuclear physics, and they would use 14 and 16 dimensional calculations all the time. And it sounds terrible, but in a 3D situation, you start to add a lot of things really, really quickly. Like momentum, for example. Momentum can have an x, a y, and a z direction, just like length can have an x, a y, and a z direction. Well, if you include a three-dimensional length and a three-dimensional momentum, you've already got six right there. You're already at six. Add in time, that's seven. So you can get these numbers go up pretty quick. The only downside is the more dimensions you add to it, the more complicated it becomes. So the idea is you don't want to just like throw all of the dimensions out there if you don't have to. Like if we're talking about something moving down the road, we don't want to be like, let's do an 18-dimensional calculation. Let's not. Okay, let's keep it as simple as we possibly can. We want to use as few units as possible, using simple representations. Okay, does that make sense? Okay, so let's take a little bit of time to analyze it. I don't know how much time we have left, not a whole lot, but I'm going to assign letters to our commonly used things that we use, our expressions. So some of the ones that we are going to be using to start with is we're going to start talking about the position of an object. And the position of an object is normally given to us by the letter x. So if I'm talking about a position, I'm talking about something being, like for example, if I say x equals 5 meters, that's going to mean that your object is going to be 5 meters away from where you started. Another way to talk about that is to say that you have a change in position. So I can write delta x, and if I say delta x equals 5 meters, this delta, this means change. So what that's really talking about is that saying that, oh, okay, I started at an original position and I moved 5 meters in one direction. Okay. Now, this position can also be negative as well too. So if you see a delta x that is negative 5 meters, that just means that it went the other direction. So since this is a one-dimensional calculation, I'm just going to draw a line. And if this is my starting position, then 5 meters would be over here, and negative 5 meters. Oh, catch up, computer. Come on. Catch up. There it goes. And no, still thinking about it. And negative 5 meters is going to be on the other side. So we got positive 5 on the right, negative 5 on the left, and put them together. That's what a position would be. So if you see me using the letter X, that normally stands for a position. Okay. If we're going to talk about a distance, normally I use the letter D. So that normally involves a distance. Now, it is important to notice that a distance cannot be negative. Okay. So like, do what? Right. So like you can't be like, hey, how long is this table? And be like -5. Be like, that doesn't make any sense. How can it be -5? So yeah, so when you're talking about distances, you're really talking about like you're not including the direction when you're using a distance. So like if you're talking about a position can include a distance to the left or right or up or down, but a distance is really just talking about a number. Like how many miles are you from your house? You're not going to say I'm negative 20 miles that way, right? Human beings are going to just use the distance and just give a number. Be like, I'm 20 miles from home. Okay. So that's whenever we use distances, and those distances aren't allowed to be negative numbers, and that's okay. They're basically just an absolute value. If it really is negative 20, we just say 20. That's just how we work. Okay. The same thing happens with speed and velocity. So speed is given by the letter I don't even normally use a letter for speed. I normally just write out speed, to be honest. Um, so I don't want to write S. I'm going to do it. I'm going to do it. Short S. Okay, but speed cannot be negative. I don't normally I'm going to go ahead and be honest with you guys. I don't normally use speed in AP Physics. What we're going to use instead is we're going to use the fancy word velocity. And velocity is given by v. And that one can be negative. That one is allowed to be. Okay, so it's got a positive and a negative value. But I think I'm going to stop there because I think we're almost out of time. So I'll try to. I don't think I've traumatized you guys yet, right? We're still okay? Good. Okay. I'm trying my best not to traumatize.